This talk will go about building Bitchat, which is an end-to-end encrypted social app and protocol. And this will be presented to you by Rebel.
So yeah, sounds like it's mic's on. So when I originally submitted this talk, it was just to talk about Nostr and the work we're doing with messaging layer security. And in the process of building that app, we started exploring what we could do with mesh networking and what we could do with low power Bluetooth. And so I've incorporated a bunch of information about Bitchat, which is an app that I and a group of other hackers developed with Jack Dorsey as part of a new sort of hacker collective that we've formed. And it was an experiment, and all of a sudden it was like 50 in the App Store. So it got way more attention than we were expecting. So I figured folks might find it interesting. To give a little context, Bitchat isn't the only thing we're working on. We're working on a whole bunch of experiments with permissionless social protocols, specifically around Cashew, white noise, MLS, Nostr, and doing a whole series of experiments around in this case. So what happened last month was a weekend experiment, ended up getting a bunch of attention and getting a bunch of pull requests and a bunch of press, and that sort of became Bitchat. And Bitchat was an experiment to see whether or not we could do an ephemeral permissionless network. And so Jack was like, well, can I vibe code it and can I make it work? And what is, BLE and how does it work? And it worked, but it wasn't like an intent to like build a big app or a plan or anything like that. Like it wasn't going after WhatsApp or something like that. It was just, what can we do with privacy? What can we do with permissionless networking? What we can do with chat? What can we do with offline and local first software? Jack is not here when he's busy, but also because the last time he tried to talk at a European free software and hacker event, people said that they were going to have a sit-in on the stage. So he canceled that talk. And you get me. I've been coming to these hacker camps since 2001 at HAL, and I have been working on and off with Jack Dorsey for 20 years on various different projects. I worked on ODO and the original stuff at Twitter. What we're trying to do, and I think this isn't just, the end of their stuff team, but I think all of us in a larger way is say, how do we make the internet work in a way that we don't have to ask for permission? How do we make it so that we can set up our own servers, our own services, connect, where you don't have to go and do age verification against services, where we don't have to ask for permission and stuff. And if you think back on the internet and what we have, that's the mission that we have here. That's the mission with IETF. And that's what got us the web today. How are we all the way back at the beginning? If you remember, TCP/IP was a rebel protocol. It wasn't the protocol that the government and the institutions, the companies and the universities wanted everyone to adopt. They wanted to adopt OSI. It was a much more permissioned protocol for how the internet would work. And so from the very beginning, we've had this conflict between, are we building an internet that's open, or are we building one that's permissioned? Are we building one where we can do our own things? And there are many, many cases of, decentralized, permissionless, peer-to-peer networks that have existed around before this. And so, what we built isn't unique, but it's an attempt to adapt to what the current technology state is. And there are many attempts inside BitTorrent and blockchain and a bunch of other projects. There's a lot of different projects that are out there. I've spent a bunch of years working on something called Secure Scuttlebutt, which was an offline first peer-to-peer social networking app that ended up never getting many people using it, but it was a heavy inspiration, both Nostr and Blue Sky's app protocol. And I don't know if people remember this, but the prototypes that we used for creating Twitter was this app called TextMob that just basically we were using it during protests in 2004 and 2005, and we needed a way of delivering SMSs to people. And so we built an SMTP server inside a Java applet and then dumped it on a whole ton of web pages and then made that so that we could deliver SMSs. And it was around these sort of group SMS things. And when Odeo, the company that Jack and I and some other folks were working at, failed to be successful in podcasting, we went and said, can we make something like TextMob and make it a bit more blogging-like? So that's a little bit of the history, and that it started out as a very hacked together peer-to-peer application and stayed fairly open like that for the first few years. Well, I'll just say a little bit more about that. When Twitter was first launched, it was a Ruby on Rails app, and Rails gives you a RESTful API by default, so no one had to build an API for it. It was just a matter of it being there and putting it together. And so the openness of it was sort of there by default. And one of the engineers on the team, Blaine Cook, had this idea that we should make it federated. We should make it decentralized and federated because it would be a problem if one person controlled Twitter. And at the time, we didn't have webhooks and we didn't have PubSub. And so we tried to build the federation on top of Jabber, XMPP. And we got the original prototype working. So there was a moment in 2008 where Twitter was federated between Jaiku, this Finnish product that Google had bought for microblogging, and Twitter, but XMPP didn't scale, and eventually Twitter as a company started really trying to consolidate itself and build itself as an advertising company, and it lost that open ethos. And it was, for me, it was a really sad moment that it happened. And sort of parallel to that happening, we have a bunch of experiments with local first and offline first social networking, where you're using signed data. In particular, Secure Scuttlebutt, which was essentially a project by this guy, Dominic Tarr, who wanted to know how he could stay online from his sailboat. And he had been playing with CouchDB, and he said, well, what if you had signed data structures that sync the data, and you gave yourself a CouchDB kind of document database? We also saw people eventually do things like FireChat and Bridgify, which were using BLE to try and do this mesh networking, and LoRa and Meshtastic. There's a whole bunch of projects in this space, and for the most part, they've never gotten beyond this community of people who like to hack on them. And which is why Bitchat's success is a little bit perplexing, because it is not a fully fleshed out app. But it ended up like about top 40 in the free apps in the App Store. And that's a little bit perplexing. So what happened? Well, eventually, the idea of an open Twitter and an open API and an open ecosystem gave way to the idea that it should make money via advertising. And then that should be the business model. And in 2012, the API authorization gets shut down. And that's where we get ActivityPub. And that's what eventually leads to Mastodon, was that first time that Twitter shut down their open API system and shut down those third-party things. So we got a lot of interesting projects from it. But we also, we lost a system. And I think one of the most essential lessons is that you can't trust companies to just do the right thing and to continue to give you open access, because eventually they will enclose it. So there's some problems, though, with some of these systems, and some of them just relate to some of the underlying technologies that are under it. I'm a big fan of the Fediverse, but it has a few major problems, which is it's very easy to build with ActivityPub. It's very difficult to build on top of ActivityPub. So I can't build an app that uses your Mastodon server to do something that the Mastodon server admins didn't enable and set up. So even though the whole network is permissionless, you can set up your own servers and build your own kind of collaboration on top of it. Users on that platform aren't able to get it. And so you don't get this sort of cumulative effect. Around 2018, I went back to Jack, who by this time had returned to be the CEO of Twitter, and I said that they should invest in secure scuttlebutt and they should build open protocols. And at the time, he said no. But what it did do is it kicked off an idea that maybe a protocol could be there, and maybe that original vision of the Federation stuff that fell apart with XMPP wouldn't work. And so in 2019, kicked off a group of people that put together a bunch of people working on social media protocols and started exploring all the existing protocols. And eventually Twitter spun off a separate company and had Jay Graber, who was a developer who had worked on Zcash and Scuttlebutt and some other apps, to run it. And their initial goal was to just build a Twitter clone that was open, that Twitter itself could use. And it is mostly open, but it is very focused on the single overwhelming big conversation. So there's no system within the app protocol for private data. There's no conception of private groups. There's a little bit you can do now where you're able to put a different set of keys on your PDS, your identity server, and authorize other things. So that's how the experiments with message layer security is working with on top of Blue Sky. So how did Bitchat come together, and what is it? Essentially, the original idea was an in-memory only network, in that you found other peers, and the conversation between other peers had signed messages, and they would send those messages back, and it would replicate out across the network. And it had that scuttlebutt thing of a gossip network, which is you would get all of the messages of your peers, and when you connected to someone else, you would relay them on. And it had both a set of public channels, like a single public channel of everybody who's overlapping with each other, and the concept of private messages. And initially, the private messages weren't very secure, and then he added noise. And it's not that complicated. And part of the problem with it is that it's meant to disappear. It's meant to be ephemeral. So, people have been using it here, and the chances of two people opening it at the same time, close to each other, to be able to talk to each other and then notice it is very low. So one of the things that's being developed and hasn't been released yet is the ability, once you favorite someone, so if there's mutual favorites, then it creates a second set of keys for Nostr identities that are just for the pair of people, and it makes encrypted Nostr messages that it puts on relays that then the other client can then go connect down from the relay. And the relays don't know, because they're new sets of identities and sets of keys for each one, the relays don't know who is communicating with whom. And there's a bunch of stuff in the Bitchat that also is sort of similar. There's padding and attempting to protect people's privacy. So what does it look like? It's super optimized. There's not much data you can put into these things, and it's an attempt to just pack it into a very teeny binary format. It's got some TTLs, which is like how long do the messages stay around, and then you start dropping them from the network. It uses Bloom filters to check the intersection of who has which messages and how to intersect them. Probably it doesn't need Bloom filters because at this point, the largest group of people using it at a single time has been like 45 or 50 people. So you could just sync the lists. Yeah. So essentially, the idea is that it does this replication, and then it could be useful in times where you had to ask for permission on stuff. And part of the weirdness of it getting really successful and getting a bunch of press around it is that it is very similar to any of the things that any of you might have done, which you said, well, can I play with BLE and see what kind of app I can build? It uses noise under the hood only for the direct messaging from peer-to-peer. And it uses the XX pattern because that doesn't require pre-key exchange. And, noise gives us a lot of stuff. It gives you forward secrecy. But as I'm going to talk about a little later, noise and sort of the equivalent version that WhatsApp uses has a real problem when you're scaling groups. I'm just skip that. So essentially, that is the app. Like, it was vibe coded in a weekend, and then we took the example of that and we built the Android app in another couple days and released it. And then weirdly took a couple days to submit it to the Android Play Store, and other people started building the app off of GitHub and having hundreds of thousands of people download it. So at the moment, we don't control our own releasing of the Android app, which is a little bit risky because we don't know if the random people downloading and releasing it on Google Play are building authentic builds of it. They're not providing the reproducible builds, or are they changing the code or not? It's open source. They're welcome to distribute it, but people think they know what they're getting. So there are some issues with this, which is like iOS and Android, they don't want you to do peer-to-peer applications. They don't want you to build, they want you to do a little bit, but they really, really want you to design the system so that you have a very smart server that runs in their cloud and that the client doesn't do very much. And so because of that, it's very hard to keep the app running, have it spin up, have it check the network, have it keep alive, and the OS very aggressively kills stuff. And so figuring out how to make that stuff work within the memory and the bandwidth constraints is quite difficult. And this is the problem that we've had with all of the local first and peer-to-peer apps that we've built over the last few years, is you're basically fighting against the operating system. And there's tremendous amount of control in the App Store and in Google Play in what they'll release and what they'll put in there. So just to give a summary before I go on to some other Nostr topics, it's all ephemeral by design. It's not meant to be a long-term app. And it's super limited. It doesn't do a lot. It wasn't supposed to do a lot. It's very confusing why a lot of people downloaded it. It is. It was not like it was a vibe-coded weekend project. I know, but he released an app that told you how much vitamin D you got in the sunshine the same week, you know. And so, sort of where it's going, the idea is to go and add some channels, add some other things like that, and also add a Cashew wallet. So Cashew is an eCash implementation that is a privacy-focused bearer token. It's kind of like a cryptocurrency that doesn't do mining. You can reconcile it through Bitcoin and Lightning, but you don't have to. And one of the nice parts about it is you can send tokens or money between people completely offline. And so it works really well for this situation. And so we've been experimenting with that. Maybe it'll work for festivals, but I also thought Scuttlebutt would work for festivals, and no one ever used it at festivals. And the battery life is a major problem. Phones just weren't meant to be peer-to-peer applications. And so, but one of the neat things about it is it gave us a space to play with Cashew. And Cashew is sort of one of the projects we're developing where it's pre-Bitcoin eCash rethought of. And it's not speculative. Each set of users comes together and they run a mint. And the mint acts as the equivalent of a local currency. And you can exchange between the mints using Lightning. Or you can have a mint with a bunch of people that use it and exchange. And it never connects out to any other currency. You can also connect it to just a fiat money system. And it's very lightweight. As I said, we're working on using Nostr to extend beyond it so that you use Bitchat to explore the local stuff, but not everything else. And then you continue to be able to talk to people. So that gets me to what the original topic of the conversation was, which was what we're doing with private communication and private groups on top of Nostr. How many people are familiar with Nostr here? Some. So Nostr is a decentralized social protocol with a series of signed data. There are, 500,000 people who use it. And it is heavily inspired by this protocol Secure Scuttlebutt. And basically the idea is each user uses a set of key pairs. They use assigned data. They have a set of objects with tags that get pushed onto relays, and users can connect to lots of different relays. And they can connect to the relay servers, which act as sort of these document databases you can query directly or over Tor, and you can put your content on many of these different servers at the same time. And the clients can connect to multiple ones. And so it's very resilient to censorship and blocking. And it's built on this idea of content routing. Under the hood, it's very similar to how @protocol works. The two are both heavily inspired by Secure Scuttlebutt. And there's the ability to, because you have key pairs, send encrypted messages between individuals that don't expose any of the metadata. And that's a neat feature. And so, because the relays can't read your messages, they don't know what content you're hosting. And you can post binary files. There's a way to do that where you don't know the content either. And you then have the ability to connect back and forth. So the thing with Bitchat is we kind of need people to take a look at it and build it and make forks of it. And if people want to keep working on it, keep working on it. But it wasn't something we expected to have 70 open pull requests in a couple weeks, or hundreds of thousands of people downloading it. So it wasn't exactly planned as an open source project. But if people want to keep playing with it or fork it or build other stuff, that's great. It's a platform for experimentation. So what else are we working on? And where did this come from? So the first thing we're working on is an app called White Noise, and it's an attempt to build a Discord-like chat app based on the Nostr protocol using MLS for scalable groups. And I'll get into why MLS is, I believe, preferable to Noise for group communication. We're building the cashew system. We built a thing called Shakespeare, which is like Lovable or V0, any of these like DevNet things for using an LLM to vibe code things, except that it knows about all the social objects. So it's very easy to make a MySpace clone or anything like that. We're trying to figure out how to take those code and then encapsulate it and then be able to share code objects between different users and groups so that you can basically build a plugin architecture that runs across the network. We launched 2 months ago, we launched a thing called Chorus, which is a Reddit-like group system where each group has a wallet to fund the moderators. So as people are members, they can go and contribute little tips that go to the moderator, and then you get sort of an open collective type system around that. And then the big project we're working on is something called Universes, which is an attempt to be kind of like a cross between Discord and OpenDoc, if you remember OpenDoc from the 90s, where you could have basically this social browser experience where you can share data between things and collaborate. And then, lastly, next month I'm going to relaunch a clone of Vine. You can see the really ugly prototype at openvine.co. It's in test flight and things, but we went and found all the old Vines on Internet Archive and other places like that and rebuilt it. And we'll probably get sued, but it'll be fun. So how do we make private groups and group communication work in an actual peer-to-peer and a decentralized network? I don't know how many of you were at CCC in 2019 when Moxie got up on stage and did this whole long talk about why federated and open protocols were a terrible idea and you can use his code, but it was too hard to innovate that way. Moxie and I used to be housemates. He's a friend. He's wrong. But you have to intentionally try and build it. And so I think that we have it working. If you go to whitenoise.chat, you can see the project as it's coming along. Thanks to a bunch of people doing standards work, we have the IETF standard for MLS, which lets us scale groups. And it scales groups in a way that noise can't. So how does it work? At its core, there's a set of binary keys that control sort of a tree of keys that control how you do the double ratchet so that you don't have to carry pairwise between all the different users. And it provides forward secrecy and all that kind of fun stuff, and post-compromise security. So this is the way in which Signal and WhatsApp do their groups, and this is the reason that they're limited to 1,024 members. It's because you're doing pairwise encryption from every member of the group to every other member of the group. And that does not scale. This is how MLS does it, where you have a set of keys that are derived from each other. And so when you need to rotate the set of keys, you only need to sort of open back up the tree back to the root key and then send it back out. And because they all sort of derive of each other as it ratchets. We don't know how much this will scale, but it makes the process of adding and removing people from groups much easier. And in test runs, we've done 50,000, 100,000 members. Not real because they're all simulated, but in theory, this should scale a lot better. If you look at the graphs here, this is the performance time around it, and you can see at the very bottom, the flat line, that's MLS as it scales between the number of users that are involved in the groups. So we think that this is a technology and a standard where we can build something that works like Telegram, but provides signal level security. And we're not the only ones. Mozilla's working on this. Wire's working on this. Lots and lots of people are working on MLS implementations. So this is what the white noise app sort of looks like. It's cross-platform, decentralized. It's built around a Rust library for Nostr MLS, which is built on top of the Open MLS library. And it does, it's supposed to be easy. It's not supposed to be fancy. So what I think is important, and I was, trying to get to in this work, and I think that what the sort of and other stuff collective is trying to do is say, how do we not make the same mistakes that we made last time, where we built a system that was hosted and run by a series of companies? Even if some of us were working for those companies, eventually you leave. And eventually you move on. And how do we make it so that we can provide good user experience and good privacy for folks? And then how do we build all these things in such a way that we don't repeat the same mistakes? How do we build these things that we don't get stuck in the same set of problems that we had before? And what I think we need to do is we need to build the technology, we need to build the libraries, we need to build the tools, but we also need to build a conception of how these protocols work, how social media works, that's equivalent to the way in which we have the 4 freedoms of free software. The 4 freedoms of free software make it really easy for us to figure out whether or not something is or is not free software. And so many times, people have come in with companies and they're like, here's this thing, and it's like our own little weird license, and we're going to just do this thing, and then we're going to pull it out from underneath you. And because we had a very clear set of definitions of what we demanded of free software was enforced with the licenses, we were able to do that. We haven't had that with social media. So in the period of early blogging, Flickr, Photolog, MySpace, Twitter, that first era of apps, even Facebook supported activity streams, which was the precursor to ActivityPub, if you remember. But we didn't have any way of saying, this is the line you're going to cross. This is the problem. This is the thing that you need to figure out. And so what we're trying to do is build and release free software that explores this process and tries to make things that are people using. And by making it clearly free software, it's a hacker collective hosted on Open Collective like everybody else, that hopefully we won't repeat those same mistakes. And so in a couple hours, I'm going to talk about that in more detail about what we're doing with that. And before I'll take questions, I just want to say, a fundamental problem with social media became the issue around platforms, not protocols. Mike Masnick wrote an essay about platforms, not protocols, an algorithmic approach to free speech. And I think it's very important that we actually build that. And what we're doing is trying to build some part of that. But it is not like the press and all that attention says, which is like, somehow we're going to give everyone a pre-made thing, and you go and you use it because someone famous released it. It's like, we're building libraries, we're building tools, we're collaborating with other people. Use them, fork them, build your own stuff. And, you know, I'll just, before we go to questions, is like, one of my favorite quotes about the internet is, you know, that we reject kings, presidents, and voting. We believe in rough consensus and running code. That's what got us the IETF. That's what got us the open network. That's what got us the internet today. And that's what's going to get us an internet where you don't have to do age verification and ID verification in order to access any website, like what has just happened in the UK. And we need to build technology that reinforces it. So with that, thank you, and I'll take some questions.
Thank you. And for questions, I have the mic. If you want to ask a question, I'll come to you.
Minor correction. I think Wire actually is running MLS at the moment. I don't think anybody else is. The other thing is,
and Wire did most of the heavy lifting in getting MLS.
And the other thing, the other detail there is the ones who are actually the only federated system that's even close at the moment is Matrix, and they've done, as to my knowledge, they've done more work than anybody else in terms of trying to strip it out. Except there may be some people at Wire or Google or whoever that are, or Cloudflare, that are trying to like coming up. There have been a lot of stuff discussed there, but obviously one should. So anyway, to make a question instead of that statement, why not just use Matrix?
That's a great question. One of the things people don't realize is that one of the very early prototypes of Blue Sky, before @ protocol was built, was building a version of Blue Sky that ran on top of Matrix. And the reality is that Matrix suffers from some of the same problems that caused us not to be able to build federated Twitter on XMPP. Matrix comes from a rewriting of XMPP and trying to fix a huge amount of the mistakes. But I think that, at least in my experience trying to actually build on top of Matrix and talk people building on top of it, it has too much of that way of thinking and legacy inside it to make it work for a whole series of other kind of applications that aren't rooms and chats and messages. So that was the reason why Blue Sky ended up deciding not to build Blue Sky on top of Matrix. But I'm a fan of Matrix. It's good, but it's not a more flexible app platform.
More questions?
I noticed you're doing a few things with, you've got a bunch of like financial things in there, you've got like Cashew Watson and stuff.
Yeah.
One of the challenges I've always got on all of these is like, how do you finance the people managing the network, and how do you make these networks sustainable? Because otherwise you end up paying companies and they have advertising, and like it all comes crashing down because managing community is a lot of work and no one gets paid for it. Is that your attempt to fix it, I guess? Is that kind of a solution, or am I misreading it?
So that is part of the solution. The solution is that we need to have a model that funds creators, funds people, app developers, people running services, that isn't just advertising, because that's the default model, and it's gonna crash down on it. But just having the ability to do payments and have wallets and things like that, and I know that the Blue Sky team is having discussions about implementing something very similar to the way Nostr works. That still doesn't give us the answer of how do the economic flows and incentive flows work, just because we can do the payments. A lot of the Nostr people are Bitcoiners. I am not a Bitcoiner. I don't, but it's a permissionless protocol, and it's relatively less corrupt than a lot of the other cryptocurrency scams. And we need some system that works. But it still doesn't answer the question, how do you do subscription payments? How do you do recurring payments? How do you pay for servers? How do you pay for moderators? How do you pay for creators? And I think that that is an essential question that we need to answer.
Yeah. I think one of the problems with secure scuttlebutt was also the bandwidth efficiency. So how is that with what you're talking about now?
Yeah, I mean, so secure scuttlebutt used signed JSON, but signed serialization of JSON in a particular JavaScript version that had a bug in it. So every time we implemented secure scuttlebutt in other languages like Rust or Go, everything else, we would have to go back and implement that specific broken version of JavaScript. I actually don't think secure scuttlebutt's problem was bandwidth. I think secure scuttlebutt's problem was the balance between processor time and bandwidth. So secure scuttlebutt does lots and lots of verification of signatures, and you had to have everybody's history all the way back to the beginning because of its signature chain stuff. And so it made it very difficult to have two devices use the same set of keys, and it meant that when you did a gossip sync with another person, you ended up using a tremendous amount of processor time to validate the data that you got. And so it worked really well if you had laptops that had really, really low bandwidth connections and lots of excess processor time. But on mobile phones, we have lots of bandwidth and relatively little processor time because the processor eats up the battery. And so one of the differences between Nostr and App Protocol and Secure Scuttlebutt is Secure Scuttlebutt had an entire signature chain, so you had to have every single message that some person did in order to validate the chain, and you had to have the whole thing. And so there was no way to drop off old history, there was no way to delete stuff. And Nostr solves that problem by just letting the messages be a little bit lossy, and you don't know for sure that you got every message. And App Protocol does it by a Merkle tree that you can rebalance. Yeah.
Could you extend the Bitchat with a Bluetooth to LoRa or to Meshtastic, like the badge? Because I was expecting to see, like, we got the badge very late.
Yeah.
I was expecting that someone would go into that direction to bridge Bitchat over Bluetooth with LoRa, and then LoRa to, again, Bluetooth to another participant that might be further away.
Yeah, and there are a few people that are building that. So people have been experimenting with LoRa, Meshtastic, but also some other sort of long-range, low-power repeaters. And if you search online, Jack retweeted some of it. But you can see some of the examples of that with source code and things that people are working on. Yeah, I was a little surprised that we weren't doing it either. But.
So,
any other questions?
Any other questions?
Well, thank you very much for coming to my talk. Suffering the sun coming through.
Thank you.
Yep.